Okay, so look, new outfit. Today we're going to do some stuff with scientific notation, of which, by the way, I absolutely positively hate to teach. So, if you do not remember the basics of scientific notation, this is what I've done for you. There is a video. It was made by Wayne Wright. Both start with W's. I put a link to it in the description, but if you can't get it, you can always go to YouTube and search Wayne Wright Scientific Notation, and it'll pop right up. It's not like he has a ton of videos, but this is the shortest video that went over everything you need to know about scientific notation that I expect you to already know. So if for some reason something in this, like go ahead and watch this and see if you can work with it, but if for some reason something in this is just like completely lost you, then you might want to go back and watch his video, because it explains how to put things into and out of scientific notation and what proper scientific notation is. He also explains it the same way I explain it, which is not exactly the way most people explain stuff. So I cover a little bit of the rules, but if you really need to know what we're talking about, then you might need to go back and watch his video too. I think it's like a 10-minute video to cover everything in scientific notation. This takes scientific notation basics one step further. So there's the blah that you need on scientific notation. After this section, we probably won't look at scientific notation again. Yay! Just saying. So, for scientific notation, it's important that you know what is in scientific notation and what is not. Just because there's a times 10 does not mean it is written in scientific notation. They're very specific about what the first number has to be and about significant digits. So, our first number is not in between 1 and 10, inclusive of 1, not inclusive of 10. That means that we have to make it in between 1 and 10. This is important because a lot of times in a lot of the problems that we have, we're going to get answers that are not actual scientific notation, and you're going to have to change them into the proper scientific notation. So in order to change this into a proper scientific notation, this has to become a 2.7. Remember, your decimal is always behind the first number. So I'm going to have to move it from there to there. So it'll become 2.7 times 10 to some exponent. And in order to figure out the best way for the exponent to go, instead of having to write it all the way out with all those 36 zeros and then move it all the way back, you just have these two rules. When you're moving a decimal to the left, that means you're going to add to the exponent. When you're moving the decimal to the right, that means you're going to subtract from the exponent. So since I'm adding to the exponent, it was 36, I have one spot that I'm moving to the left, so that's going to add 1 to my 36 and make it a 37. Now it's in proper scientific notation. Down here, this isn't proper scientific notation because it's not 1 or higher. So I'd have to move it once again so that it's behind the first significant digit, which will put it behind a 9. So that'll make it 9.0, or just 9, times 10 to some exponent. Since I'm moving it to the right, that means I need to subtract from my exponent. I moved it 1, 2, 3 times. This 3 minus my 3 here gives me a 0 there. That is proper scientific notation because it has the 10 in it. However, that's not what that number really looks like. So if they want the answer in scientific notation, because they gave you the problem in scientific notation, that's the way it should look. However, if you wanted to know what that real number was, 9 times 1 is just a 9. Because, you know, any number to the 0 power is 1, so 9 times 1 is 9. Now, the whole point of all this is so we can learn how to multiply and divide scientific notation. It's not nearly as hard as you think it would be. We have a number here and a number there. We have a 10 here and a 10 there. Since it's multiplication, we can do things in any order we want. So I'm going to choose to multiply my big numbers in front first. 2 times 4.34 gives me 8.68. And then I'm going to choose to multiply those. So that's 10 to the 5 plus 8, because they're like bases, gives me a 13 power. Now, we could go ahead and multiply that out if we wanted it, but since they gave us our problem in scientific notation, they're going to want our answer in scientific notation. So this is what they want. Please make sure it is in proper scientific notation. Since that's in between 1 and 10, we're all good. When I come to number 12 over here, however, not so. So 3 times 7 is 21. 1 times 3 is 3. 3 times 2 is 6. So multiplying those two, we were all good. Then multiplying these two, I get 10 to the 5th power, because 3 plus 2 is 5. Only that's not proper scientific notation. So we have to make it proper scientific notation. So I need to move my decimal point one place to the left. So that becomes 2.136 times 10 to the, when I move it left, I have to add. So 1 plus 5 is 6. Make sure you leave it in proper scientific notation. Now multiplying it seems pretty simple. Everything's grand, lovely, and wonderful. What about if we were dividing it? Problem number 16. Says 4.9 times 10 to the 9th over 7 times 10 to the 3rd. Just like we could pick and choose what we multiplied over here, you can technically do that over here, only we're not really picking and choosing, because we know we want our answer to end up being in scientific notation. So since that's the case, I can do my numbers in front and then take care of these numbers back here. So when I do this division, 4.9 divided by 7 gives me 0.7. And then when I divide, that means I have to subtract my exponents, so that's times 10 to the 9 minus 3 is 6. Is that proper scientific notation? No. So we need to move our decimal point back so that it becomes a number in between 1 and 10. When I move my decimal point to the right, that means I have to subtract. So instead of it being a 6, it's going to be a 5. Sometimes they're going to give you problems where you have to do multiplication and division. Doesn't matter which one you do first, whichever one makes you feel good, because you can do multiplication and division at the same time. So there's that section done. Classwork and homework. I'm trying to write it up here. Classwork, page 239. Practice exercises. Numbers 2, 4, 6, 8, and 17. Homework, same page. Practice exercises. Numbers 5 through 15 odd. And that's it for section 6.4. See you next week.